Is there a cure for cyanide poisoning? Have you ever wondered what happens when cyanide enters the environment and how it affects both humans and wildlife? Today, we will discuss cyanide poisoning, particularly in the context of the Baia Mare cyanide spill. This event had devastating effects on aquatic life and raised important questions about treatment options. Cyanide poisoning occurs when cyanide compounds disrupt the body's ability to use oxygen. This leads to cellular suffocation, which can be fatal. In fish, cyanide poisoning is especially harmful. It can quickly affect their respiratory systems and metabolism, often resulting in death. From a medical perspective, there are treatments available for cyanide poisoning. However, their effectiveness largely depends on how quickly treatment is administered and the severity of the exposure. In animals, including fish, treatments focus on detoxifying cyanide by converting it into less harmful substances. One common treatment is the inhalation of amyl nitrite. This helps for methemoglobin, which binds to cyanide and reduces its toxicity. Another option is the intravenous administration of sodium nitrite, which induces methemoglobinemia. Sodium thiosulfate can also be administered either intravenously or orally. This compound converts cyanide into thiocyanate, a less toxic substance that the body can excrete. These treatments aim to lessen the toxic effects of cyanide by helping the body eliminate it from the bloodstream and tissues. However, applying these treatments to fish in the wild is quite challenging. The success of treatment varies based on exposure levels and environmental conditions. Cyanide fishing, a harmful practice where cyanide is used to stun fish for capture, has caused severe environmental damage. The Baia Mare cyanide spill is a prime example of this. It led to massive fish kills and long-term harm to aquatic ecosystems. In such cases, the scale of poisoning makes treating individual fish nearly impossible. Research shows that even with treatments like methylene blue and antibiotics to manage secondary infections, recovery for fish is uncertain. Mortality rates remain high. Additionally, environmental factors such as increased water temperature can worsen the effects of cyanide poisoning. This increases fish mortality and prolongs recovery times. While there are chemical antidotes for cyanide poisoning in animals, including fish, these are typically used in controlled veterinary or aquarium settings. Unfortunately, there is no practical or widely available cure for cyanide poisoning in wild fish populations affected by environmental cyanide contamination. The best approach to protect fish and aquatic life is prevention. Avoiding the use of cyanide and controlling spills is essential for preserving our natural ecosystems. Understanding these issues is vital for outdoor conservation efforts and reporting environmental damage.